give it. All right, I think I'm going to start. I think there might be some people walking in, but I'm just going to say first up, so we're just kind of doing a fresh start now. So if you haven't managed to get any APIs working, don't fret. Nothing, it's not going to be, you're not going to need them. Just make sure that you have downloaded the GitHub folder, because that's where the data that we're going to be predominantly using is. However, we're going to just quickly start with actually, how do I get tweets out of Twitter? Once now I have this API, what do I do with it? So for this, we are, as Anna has already mentioned, we're going to use Twitter. You can use rtweet as a package, and I hope you all have installed that. If you haven't, then it's probably a wise idea to, at the start of this new Markdown document, that I should probably mention what it is. If you go into the Twitter folder on the GitHub, there is a Markdown file that is called Twitter R tutorial, and that's what we're going to look at the moment. Okay, and so while I'm talking, the first thing to do is, if you haven't done so yet, install the packages that you see there. So basically just run this. If those DevTool packages are not working, don't fret too much. We don't really need them. They're just there for sort of reproducibility purposes in case you were going to run this entire Markdown. But they're not actually necessary. All right. So once you have done this, you can also then just load all the libraries into your R session, which is useful. All right. So let's talk a little bit about Twitter, the package. So now that you have your API and you have connected to it, so you have set up your API key and you've created a variable where your API key is stored, you have stored your API secret, and you have stored your token and your token secret, all you need to do to connect to Twitter is actually run this little line. So this was not necessarily in this. I've just added this, but it was in the other, in the API setup. But just to remember, this is what we run. So this is getting you to Twitter. So next, what we want to do is we want to download some tweets. So with Twitter R and with rtweet, what you can do is you can download your timeline, you can download trends, and you can search Twitter. So that's super, super useful, searching Twitter. You can't just search for hashtags, you can also search for just any phrases, anything you might be interested in. But the way that Twitter is set up is that a lot of people do use these hashtags to talk about a specific topic. So it is kind of a good start almost to look for any particular hashtag that we're interested in. So what we have done here is that we're saying, okay, let's have a look at what is happening at the useR 2018 under that hashtag useR 2018. So if I just run this, I get an object that's actually not super, it's like a horrible list object, so you don't really want to touch that. There's actually a really useful function that is the tweet list to df, so that just makes a data frame out of this horribly nested list object. So that's what we want to run next, and then we'll have a look at what our data looks like that we have just downloaded. So we just asked it to download the 3 most recent, so this is what I'm asking for here, the 3 most recent tweets that used the hashtag useR 2018. And this is what I'm getting after I have converted it to a list object. So I get the text. Anna just kindly, I think Anna just kindly did this part. So this is my Twitter handle. So this was one of the most recent tweets. It's actually brilliant. And oh, it's yours. Awesome. Thank you. This is really cool because now we can see that this is really bringing up the most recent stuff. Yes, I love it. So that's the text that was in those tweets. Then this is just asking, have I favorited it or not? That's your personal favorite button. Remember, there are likes on Twitter. You can like things in case anyone is confused. So it's asking, this is just returning whether I have liked this tweet, yes or no. I'm not on Twitter at the moment, so I haven't liked it yet. I will. There's a favorite count, how many other people have liked it. Whether it's a reply to a particular, I think it's a particular person. In this case, it isn't. Then when it was created, whether it's been truncated, whether it had to be shortened because it didn't fit, and then it gives you the ID. That can sometimes be useful. So every tweet has an ID, and you can actually with Twitter, with the Twit R, big R, capital R, package, you can actually look up that ID as well and potentially even look up replies to a particular ID. So just to show you guys how you can figure out, I need to go this. So if you have a tweet like this one here, and you want to figure out what its ID is, then its ID is just up here in the address. So that's the ID, just in case you were wondering where this ID thing comes from. All right, so every tweet has a unique ID, and that identifies it, and this can be helpful. And then you have the screen name, so that's the person that is tweeting it. And yeah, you can have, you have a retweet count, so that's how many times it was retweeted, whether it is itself a retweet, and yeah, and then also some longitude and latitude in case the user has actually specified where they are and they're giving you this information. Often this is actually not filled out. So these are sort of the things that you're getting if you're searching with Twitter. All right, so back to this. So this is so here this is just going through them again. So in case you were confused by what I said, you can just look at this again. So this was a really simple search that we did just now. We can actually do much more complicated searches. And how we do this is that we generally just use search engine logic. So for example, if I was interested in tweets that were using the hashtag useR2018 and the hashtag rstats, then I can use this tweet, I can use this search phrase here. This is just looking for things that are using hashtag useR2018 and hashtag rstats. And I'm now giving out the first 10 tweets, the most recent ones. So let's have a look at that. And then let's open it down up here. And you get all of these. So now we can already see that this RT thing here, I'm going to mention this. So when you see an RT at a handle, so does everyone know what a Twitter handle looks like? Anyone confused by this? So just for people who don't want to say that they don't, so at something, a name, that is someone's Twitter handle, someone's name, and you're talking to that person. So when we see in the text that any tweet text that starts with an RT at handle, that means that is a retweet of that person's status. So of that handle's person. So if it said RT at trashy stats and then there was some text, that means someone has retweeted my status, my tweet, and we have picked it up with using this Twitter API. And otherwise, it's exactly the same, the data frame that we just created. All right. So this is how you search. You can have sort of, if we go to, sorry. Okay. We can have other much more complicated search queries. We can look for tweets from a specific person by specifying from and then their Twitter handle. Remember, anything that comes after the @ symbol. So if I specified from Thomas ASP85, then I would get all the tweets from Thomas Lynn Patterson, one of the keynote speakers here. I could look for things that were sent to Thomas by looking at to Thomas ASP 85, and that would give me anyone that would have tweeted at him. So that is, tweeting at someone is typically when the handle comes first in your tweet, that is tweeting to someone. And then I can look for, as in Google, I can look for exact phrases by quoting things. I can negate things that I don't want to see, so I can look at, for example, the r/stats hashtag, but not look at use r hashtag. I can use or, and things like that. So anything you're familiar with in your typical in your typical like Google search query probably works here as well. And the best way to test whether it really works is by putting it into your Twitter up here into the search function up there. And if that works here, then it will work. Then it will work using R as well, generally speaking. So that's a good test. Awesome. All right. Any questions? Just stop me, please, if there's anything. So with the search Twitter function, you can also do a lot more restrictions in case you wanted something a little bit more specific. So you can restrict the language, which is sometimes useful. Maybe you don't speak anything but English, so you can restrict the language to English only. Or maybe you are interested in a particular sort of like language market, and then you can basically provide that here. You can locate users within a given radius using your latitude and longitude, but remember, a lot of users don't necessarily specify or let Twitter use that data, so you're probably going to end up with very, very little tweets, so that's maybe not the best option. You can ask Twitter to return only tweets that came after a certain tweet, which can sometimes be useful if you have maybe a tweet that had like a big, big impact, and then you want to see how has the trend developed after this tweet came out, so you can specify the tweet ID there, and then that will make sure that only tweet IDs that are greater than this will be returned to you. So that's tweets that are newer. You can do this max ID things, which is the opposite, that specifies anything that has happened before this tweet happened. So this is sometimes quite useful to see how temporal changes sort of in behavior. You can also do this maybe a little bit more sort of like time focused, where you actually give a date and a specific time potentially in order to restrict your Twitter search. So when we talk about time, what we should note here is that Twitter is quite restrictive in how much data you can actually get. Twitter restricts you to only get data from the last 2 weeks. So always remember this, you cannot request any data that is older than 2 weeks using your standard API. So that's just something to keep in mind. So when we collect data, it's always important to document the process of let me try to find, of how we got the data. So, and I found this brilliant tweet by Mike Kearney, who is the package author of our tweet, and he's saying that he would, this is just part of reproducible research. Please make sure, like especially if you're an academic, if you work in a company, not so much, please make sure that your collection is clear, accurate, and properly described. And what he's saying is, at a minimum, please tell us what source are you using in order to download your Twitter data. At the moment, you are all on a standard API. So that is sort of the lowest level API, and this is why you can only download tweets that are 2 weeks, that are less than 2 weeks old. There's also a premium and an enterprise API if you're interested, but Twitter is going to, ask you to pay some money if you're using these things, obviously. It's important to, once you have cited this, it's important to cite what package you're using, what R package. Here we're using TwitR, and then we also, the specific function that you're using, and then what search query you were using, and any filters you might have been giving to the search Twitter function. So now we're going to come to what we were interested in talking to you about in this tutorial about, and that is downloading tweets for a time series, because that's what we're going to be working with. So again, no one needs to follow this part because we've already done it and you won't be able to follow this. So what we were interested in was how the royal wedding was going. So the royal wedding between Meghan Markle and Prince Harry obviously happened on the 19th of May 2018. And we wanted to just kind of sample representative tweets around the time. So obviously if Anna and me had started this last week, we wouldn't have been able to download enough tweets because the wedding is way older than 2 weeks by now. So what we did was that we collected tweets, we collected 3,000 tweets every day for 12 days, beginning from the 17th of, for like months, we collected 3,000 tweets each week. That's what we started with, beginning from the 15th of March till the 31st of March. And we always did it on a Thursday morning Australian time. And then once we got closer to the wedding, so from the 17th of May, we did 12 days of sampling every day, 3,000 tweets. And we collected tweets that were containing the hashtag either Meghan Markle, the royal wedding, hashtag Prince Harry, Harry and Meghan, Meghan and Harry, or royal wedding. Because we weren't quite sure when we started this, sort of out in March, which hashtag would be popular. So we kind of did a little Google search, had a look what people were talking about and what hashtags they were using, and then sort of put all the hashtags in there and then sampled representatively over all of these hashtags. So the way we did this here was, again, use this search Twitter function, using all these hashtags that we had identified, and we just used an or in between of them. So they were giving us tweets that were containing either all of the hashtags, a subset of the hashtags, or just one hashtag, for example. And as I said, we sampled 3,000, and we used a language setting that was just English. In order to set something like this up, and where you don't want to run this every day yourself, so it would be crazy if every day you woke up on a Thursday morning and went, I need to do this. So that's not a good way. If you have access to a server or or a computer that's running all the time, then it's best to do this via a cron job. We're not going to explain how this really works here. We've given a kind of little sort of taster of how this is done, but basically what you do is you create a script with all of your authentication details and the Twitter, the search Twitter function that you're using, and you can then and also of course a saving function of saving these things into a CSV file, and then you make sure that this script is run on, however often you want it to be run. And you can do this using this cron job add-in that is a plugin into RStudio, and it's really easy to set up because it's just a point-and-click application. So this is how you would do this if you wanted to do this. Obviously, we can't do this now because that would be crazy, and we don't have weeks to spend here. The other thing I should probably mention is that we didn't specify that we wanted to collect just the most recent tweets. What we specified was that we didn't specify anything, and so we are getting here, when we're doing this, we're getting here a mix of real-time tweets, so the most recent one, as well as the most popular tweets. So the search Twitter function lets you actually specify 3 things, which is either the most recent, a mix. If you don't specify anything, you get this mixture between most recent and popular, or you can specify popular and in the result type, and then you get the most popular tweets. So that's always good to know. Yeah, and now Anna will show you how, because the data is all there for you in the data folder, how you can use the data in order to do some cool analysis. Everyone good so far? Any questions regarding how to do this? If you have any questions regarding the cron job setup, like come talk to me after, because that's a bit harder. So we just wanted to give you a taster and to say that that's what you want to do.
Thank you, Saskia. Okay, so now we're gonna try to do a little bit of text mining in R. Well, not really text mining, but textual analysis in R. How many of you are familiar with the tidy text package? Is anyone? Okay, we have 1, 2, 3, and 4. And how many of you are familiar with the tidyverse world? So the pipes and, okay, so we have a few, we have probably. I'm gonna try to explain a little bit the steps that we use. I'm not gonna go into the details, of what every function is. Probably this part is gonna be a little bit fiddly in some parts, but I hope that at the end of the day you will have a basic idea of how you get started with analyzing your text in R. So I just want to mention this, that we are going to focus our tutorial on the tidy text approach. Of course, for who has done other, who is kind of familiar with how you do text analysis in R, this is not the only way, the latest way in which you do this type of analysis in R. And for who is familiar, for example, with the corpus or the TM package or the, yeah, exactly, so there are some people here. And that is kind of the classic way in which you do this type of analysis in R. And we decided to use instead the tidy text approach because we thought it was a better, it was a more intuitive way to get started with the text in R. And we're going to give an introductory part of this, but for who is more interested, so we took a lot of our scripts and a lot of information from this book, which was written by Julia Silge and David Robinson, maybe they're pretty active on Twitter, so you might have heard of them. And especially because they also have a case study on Twitter, so that was really useful for us. So I'm going to start by, so I would like you, if you want to follow this interactively, so we're going to start by loading the tidy tools, which are tidyverse and the tidy text package, because we're going to use all functions that are needed inside those packages. And I'm going to load the data as well into Twitter. So as you can see, you should have, if you downloaded our GitHub folder in R, you should have a Twitter data folder, which contains all of this CSV data inside that Saskia just described earlier. And the next chunk, so with this lapply, loop, and do call function in order, will load for you all the data into R and combine it into a data set, into a unique data frame. And if we look at the head of this data set, so it is a table, which is the way, so if you look at the head of this, is it big enough? So this is a big, we're in some issues. So this has exactly the same structure that Saskia just shown before, just in a bigger version. So it's a big data frame that contains 75,000 tweets, which are all the ones that we have been downloading in the past months. And it has the same structure that Saskia just showed you. So the actual tweet is in the text column, and then you will have all other information like your favorite. So if this was it's been a favorite or favorite counts. And the variable, there is a few things here. What we are going to use today is mainly the text, because here is where the text is. We're going to also, we will be interested as well in this variable called created, because you might want to plot a time series. So for example, when the hashtags were collected, or sort of like, yeah, so this gives you the chance to have the time where the tweet was made. And important also is the screen name. So screen name tells you the person that has tweeted, and so on. So we will use some of these columns in our analysis. So now I just want to, introduce you a little bit to the tidy text philosophy. So this philosophy is probably, if you're familiar with the dplyr philosophy, you will know that Hadley's head. So every row is one observation and every column is a variable. In our case, our observations are words. So in a text, sorry, not words, but are pieces of text. And what you define as your observation is up to you. So the tidy text package offers you a very, very useful, offers you a set of useful tools. And the first one that I really would like you to understand and appreciate is this called a nest token. So what I'm doing here, so let's try to run this bit. So what I'm doing here, I try to comment it, but stop me if you have a question. So I'm taking all tweets. So all tweets is the whole tweet put together. I'm using filter to remove the duplicate because, of course, since we download it every 2 weeks, 3,000 tweets, sorry?
And every day.
And also every day we will have duplicated tweets. So you want to remove rows that are the same. So I'm removing all the duplicated tweets. I'm just going to create a tweet ID column. Mutate is a dplyr function that creates a new column. And the column will go from 1 to the number of rows of the data frame. I'm doing this because there is well, this X1 column will not be unique. I think there was another ID inside. It probably is this ID. But sometimes, no, it's not this ID. There was another ID, but it was not the same. It was not unique because data were saved. Doesn't matter. I mean, I'm just going to create a unique ID and remove this column X1, which was not unique. So this is not really that important. But what is important is this line, a nest token. So the nest token, so the key concept in the tidy text is the concept of token. Token, as I wrote here, is the piece of information that you're interested in. If we run this one, you will see, maybe it will take a little bit. What it does is that it unnests the text, the input text. Text is our tweet. And it creates a new column word, and it tokenizes it by words, which means that it splits up all your tweets into words. So then after this, you end up with a tidy version of your tweets that contains where every row is your token. So you have one token per row. And then every row in your case is a word. But if you look, there are other options to define what is your token. So for example, if you go into the help page of a nest token, you'll see that you can, words is the minimal one. You might have characters, you might have, another way that we'll try now is the n-grams. So if you launch the next chunk, I'll do the same initial step, but I'm going to unnest it by n-grams of length 2. What this will do is that it will unnest it using groups of 2 consecutive words. So you will have one and then the other one and then it keeps going. So that this will be your token that you will be working with. And as you can see from here, then you can actually link up, and it is really well described into the textbook, how you can then use this and apply all the tidyverse tools to make your summary, your frequencies, analyze whatever the words are, and so on. So as I'm saying, I think the tidy text packages are offers really sort of intuitive tools to get your text, to get you started with cleaning up the data. And then it's really interesting as well because it offers also all the options to convert the tidy text format into the classic way, for example, of the corpus and the document term metrics, which means that if you're used to the classic version, you can go from the tidy text way, from the token way into the document term metrics and the other way around. So it's not that if you're used to a certain type of text analysis, you're stuck with it. You can actually merge them all together and combine it in your script. So you can go from one to the other one, and the tidy text package offers all these tools to go from one way to the other one in seeing your text. Because there are a lot of tools, for example, to do, I think, topic modeling that Maria will talk about that are not yet, I mean, they are available in the classic formats. Am I right? I don't know. Sorry.
We're going to use the CAN package for that.
Yeah, exactly.
You can even really do that. Just because of the way that topic modeling works, just the map you find out. So
Yeah.
you don't really type those tokens, which are fantastic to simplify your text.
Yeah. So it's like this is the first way in which you can clean up your data, but then Tidy Text offers these tools that you can use. I think they are all called, that helps you to actually convert from one to the other one. I'm not going to go through this now, but this is just to tell you that if you are used to certain analysis with the TM package and so on, you're actually able to go cross packages. Okay, so let's now start with the analysis of our tweets, and I'll do a little bit of string analysis, hashtag analysis, and so on. So the first part will be a little bit of cleaning our data. So as you could see from the head of the tweets, the text contains a lot of rubbish. So we are going to start by cleaning up a little bit our tweets. So in this chunk, what I'm doing is that, again, the lines that we had before. I'm going to create a new data set called all tweets. So I'm going to modify the current all tweets, create a unique ID, remove column 1. I'm going to create this new column, which will be interesting later. So there is so if we look at all tweets, sorry, not this one, heads of all tweets, you can see that the text, if you can see from here, some of the tweets starts with RT. This is not actually they start with our tweet and then the handle of the person that was retweeted. This piece of text is not actually part of the tweet. This is just the default way in which a tweet that is retweeted will be downloaded by R, which means that the actual text that you need is probably this one. This is a wind up shortly and so on, but the text starts with this one. It's not that this information is useless. So what we want to do is that we don't want to have it in our text analysis, but we want to keep the information about the person that was retweeted, because maybe you want to know who are the handles that are most popular, that are most retweeted, and so on. So what we're going to do here is that we are going to use, and when you work with text, you need to be a little bit familiar with strings and how regular expression works. We are very beginner as well, and in the textbook, actually, they offers you a lot of ideas on how you can do several things, especially for text analysis and Twitter as well. So what we want to do here is that we want to take everything so with this string extract is part of the string.r package, and what it does is that it extracts from the text column, which is where the tweets are. It extracts the reg retweets, which is this regular expression. So it will extract this part. It will create a new column, which is called retweet from, where I will know, I will have this piece of text. So I will know who retweeted this. And then in the next part, I'm just going to remove the RT part because I don't need that. So this is simply what I'm going to do. So if I run this one, I'm just looking at these 3 columns. I will now have a tweet ID. I will have a new column called retweet from, so I know who was retweeted. And is retweet is already present when you download your data. So you know if that line, that tweet, is a retweet or not. So this is just for me to double check that wherever I have a handle that was retweeted, it's also a true in is retweet, because I cannot have a handle is retweet from if that was not a retweet. Okay, so now this is how I set up in order to understand who was retweeted or not. The next section, instead, there's a little bit more of regular expression going on. So we borrowed actually this part from the textbook because they were doing a similar things to what we wanted to do. So in this part, we are gonna now tokenize our text. So I'm gonna call this new data frame all words. And I suggest, if you want, that you might want to run this part, because we are going to then create, or maybe we'll see. Because there will be a challenge at the end that you might want to do it. I'm just conscious about the time. So yeah, let's see how much. And so I'm going to create this new data set called all words, where I take all tweets, I remove duplicates. I'm going to replace this big regular expression that we borrow from the textbook that contains a lot of rubbish sort of information. I'm going to remove this from the text, And then I'm going to use the unnested token. So now I'm going to call the new column word taken from the tweets, and I'm going to use this particular way of making a token, which is based on a regular expression. And this is really useful when you want to, for example, maintain hashtags or handles or heads in your tokens. So I'm gonna then, the last thing is that stop words. Stop words, the tidy text package offers this database of stop words, which are words that you might not need to actually make, lexicon, topic modeling, or you might not really want to have them into your text. You might want to filter this if you want to keep some of these words. This is already present in the tidy text package. So what I'm going to do is that I'm going to remove all these stop words from our text because I don't want to analyze them. And after we've done this, this is our way in which we clean all our data. We are ready to go. One thing that probably you noticed that I didn't mention is that now we have, of course, one word per row, and we still maintain the tweet ID. So tweet ID will tell us that all these words come from the same tweet. Of course, there is still some rubbish there because in the stop words, this is not in the stop words, but it's okay. You might want to do a more deeper cleaning if you really want to. Yeah. How does it handle emojis? I don't think that emojis will be maintained here. Yeah, because they will be all crypted into weird text. If I look at old tweets, and then I look at text, I think there will all be sort of these words like this that I'm pretty sure they'll all removed. Because, I think, we haven't...
Yeah, I think there are several packages that you can use if you were really interested in that to get them out.
Yeah.
But sorry.
I think...
We can have a chat later.
I guess, yeah.
Yeah.
Yeah, exactly.
Yeah, exactly. You can.
And
We're just not doing it here.
yeah, and what you might want to do is to include them into a nest reg expression because it will retain all those Unicodes in there as well as it retains the hashtag and the handles. And then I just save all this data set because, this was actually just for you because you might want to use this data later. I don't know how much time we might have to go through all the analysis because I know that Maria will show the YouTube part and we want to have time for the challenge. Yeah. Yeah, okay. So maybe I'll show another few things and then...
Guys, what do you think? Do you want, we have a challenge at the end where we give you some quite simple exercises to do. Would you prefer us to go more deeply into details of how you access the data, or would you prefer to have more time for challenges?
You want to look at this? Yeah, okay.
If you can do things that they aren't showing now.
Yeah, so
At the same time, you do some practice.
yeah, if you want to follow this, we will put this solution to the challenges, and in the challenges it contains sort of extra things that you can do, so it was a challenge, but it's okay. We didn't, maybe we wouldn't have time to do everything. So let's do what are the things that you can do with text? Of course, there is a lot of, we start with the very basic things. So everyone, one thing that you might want to consider doing, for example, when me and Saskia studied our search, we had those 6 hashtags. We might have, for example, thought, are all the hashtags useful for our search? Should we change the hashtags? Are something to be changed? So what we did just at the end, actually, we wanted to check, for example, the frequency of how many times every hashtag was actually used, how many of the hashtags that we used for our search were used. So here I'm going to use, again, mutate to create a column which is our tweets, which is true if the word, which is our token, contains the hashtags that we searched. String to lower is still part of the string.r package, and it converts all the text to a lowercase so that it can match it, otherwise it won't match. I'm only taking our tweets because they will be true. I'm going to do some grouping and counting. And then at the end, this is, I haven't loaded the hashtags, sorry. I think it was at the beginning. Okay. Uh-huh. Do you have, and this is the results that it will give you. So this is just a simple bar plot showing the frequency of your hashtags. Do you have questions about the functions used here or like some, yep, it's all clear? And the next thing that we wanted to do is, of course, everyone likes word cloud to see your data, your text, how, what's the most frequent word and so on. We managed to find this nice package, which is word cloud 2, which actually allows you to make a word cloud of a shape that you want. So these are pretty much the same things that I've used before. What I'm going to do is that I'm going to filter out. I'm gonna remove all the hashtags from our search this time because we didn't want to keep them. But then I'm gonna still only retain the hashtags. So we string detect is true or false. Is true if your pattern, if the word matches your pattern. And then I'm gonna count how many times the words appear, and I'm gonna just filter out for things that are pretty common. And using this, you can make, this is an example of an interactive word cloud. And for the other one, yeah, the other one will be here. Yeah, this is another option, for example, in which you can create. Maybe you can see it bigger from here. So the other one was a general word cloud, which is an interactive word cloud. But also you can give a picture that you want to make, you want to put your text inside. In this case, we were looking at the royal wedding, so we just decided to download a JPEG of a crown, and then we just put the text inside. Saskia had some issues with it initially.
It might be a bit fiddly. It sometimes doesn't work super well, and you just have to try again. And at some point it works, and I couldn't get any rhyme or reason why it didn't work, and then all of a sudden it started appearing. I think I sat there for maybe half an hour.
Yeah, that's probably why. Yeah, that's probably why we put the actual picture, because we were not sure if it was going to work actually right now. As you notice here, and then this is the biggest hashtags is win. And we think that actually this is sort of a bias of the way in which we sample our data, because we downloaded all our data on a Thursday, which is after Wednesday, and we figured out that there is this competition going on every Wednesday. I think it's a lot of companies say they're trying to entice users to retweet their content and so that they will win a prize. And pretty much we might have, and so users retweet a lot of times this company's product with this Win It Wednesday, and this is why we got all these weird, which are not really related, which probably, at some point we went and looked for some of the most common tweets. This was actually, it's quite a big picture, but this was one of the prizes, which was Meghan and Harry. So this might be an artifact, but it was also connected to other, it was picked up because our hashtag was there. Yeah. And another way that's, I think I might just show you the last analysis, and then I'll give the words to Maria, and maybe I'll let you go through the rest of the tutorial because otherwise we might not have enough time. And other things that you might want to do, if, for example, to find what are the popular accounts and tweets. So, for example, who was the most retweeted one, or who tweeted the most, who was the most retweeted person. So here we are going to find we are going to define a new data frame called popular account. I'm going to take all tweets. I'm going to just take the retweeted people because we want to know who was the most retweeted. I'm going to retweet by that. I'm going to group it by that variable retweet from that we created earlier. So to know who was retweeted. And I'm just going to plot it to see who was the most, oh yeah, there is Nitar, right. And okay, so as we can see that the Kensington Royal is the actual official account of the Kensington Palace. This is why it was the one with most retweets. But in this case, yeah, it was tweeted very important information about the designer of Meghan Markle's dress. So just on the day, yeah, this was the day of the wedding actually, May 19. Yep. And in this part instead, what we wanted to do is we wanted to see, apart from this, who was the most retweeted person. So here again, we take all tweets. We group it by we group it by, oh, let me see. Oh, yeah, this is all tweets. So we go back before we unnested our tweets. We group it by text and then count what are the popular tweets. No, wait, what am I doing? I think this one was we were interested in. So we take all tweets. We only keep the ones that were retweeted, and we take the one that was retweeted the most to find out who was the popular people. And this was it this one? Lucy Senpai. So Lucy Senpai was the most retweeted tweet, had the most retweeted tweet in the whole, in our own sample. And
No, this was in general. So
in general, actually, because we found the article.
yeah.
So what we did is that we went to look, who was this Lucy Senpai? She's just a normal, I don't think she's famous or anything, but she tweeted this picture. Yeah, she tweeted this picture, and this is the tweet that was actually the most retweeted. And I think this is Meghan Markle 15 years later. Yeah, 15, when she was 15, and she took a picture at Buckingham Palace, and then the picture with her married. And we found out from the news, I think this one is did a little bit of a search, and this was actually in an article, just to say how important it was, that tweet. More than 6 million tweets on Harry and Meghan's big day, and Lucy Senpai's tweets was also there. So we picked it up, even by just looking at a sample of tweets, we managed to pick up that she was the most retweeted, she had the most retweeted tweets in the whole campaign, in the whole pre-wedding time. And, was there any question? Maybe, yeah, this actually was the last part, so I'm just going to run it quickly without explaining maybe too much. The last thing that we wanted to do was to plot, we wanted to plot a time series of our tweets. What we did is that, the first thing that we did is that we take the all words, so the unnested version of our tweets. We then separate is another dplyr function in order to split. You can do splitting of your variables. So we wanted to separate the created column that I showed before into day and time. And so that we have a column for day, a column for time. I'm going to then retain, again, only the hashtags to have less people, to have less tweets. I'm going to take only, I'm going to only take retweets. I'm going to group it by day and word. Pretty much what I'm doing here, what I'm doing in this part is that I want to know what is the maximum. If I run it, it will be more clear then. I wanted to know here what are the tweets, the most popular tweets, because what I wanted to plot in my time series was something that is not too trivial, because of course, like maybe there are these competition things is everywhere. So maybe we wanted to remove the super retweeted tweets and keep the ones that are a little bit less popular but still popular. Otherwise, you might end up with just your, hashtag of search. And yeah, there are around 5,000 hashtags, so we couldn't really follow them all. So what we did is that we remove our search of hashtags, and after creating this common tweet hashtag, I remove all of these, the first most common hashtags. And so that I had the averagely popular tweets. And then I'm just gonna, again, filter, group by, do the same counting that I've done for the histogram. And then I've used ggplots and then plotly, probably. ggplotly is ggplotly is from the plotly package. I'm gonna write it here. And it allows you to wrap your ggplots into an interactive graph. It's actually the author of ggplotly is Carson, who is just giving a tutorial right now. And so this is what we got. We got this time series of the averagely popular tweets. And just to mention a few things to end up, what we noticed was that out of this interactive one, so we had a peak, of course, of royal wedding tweets on the 20th of May, because it's this one, just after the wedding. We also have a pic of the Commonwealth's heads of government, a pic at this, for this hashtag. And what I found, which I think is this one, or this one. And I went back to search, and you can find out exactly how I did to went and search. And what I found is that on that day, actually, Meghan Markle and Prince Harry went to speak at this Congress, which was the Commonwealth Heads of Government meeting, which was held on that day. So we could kind of find out what was happening at that time. So let me know if you have any question. I hope I'll give you a little bit of introduction on how you can get started with text analysis. This is not really, everything that you can do, but it's just to give you an idea of how you clean it, how you make it into a nice and tidy format. And then now Maria is going to tell you a little bit more of the complicated models that you can build with your text. Do you got any question?
Are you still with us? Yes. You still alive? Another half an hour? Okay. Now we're moving on to YouTube world. So from text to more relaxed stuff. So we're going to have a look at videos, right, and how we analyze videos. So we'll be looking at both sides. We'll be looking at textual and non-textual information. Just give me a second to plug it in. Now, all the information that all the tutorial files I'm going to show you. Now, again, we'll be doing some manipulations just so that you feel like how it works. All right, but at the same time, you can download everything. So I would suggest that you go to GitHub and you go to YouTube folder, and the file that I will be showing you is called test. It's testing things around, so yeah, let's test it. Now, that file will be modified after the class. Why? Just because I know that a couple of people, they still have problems connecting. They still have problems with their tokens. All right, so I've put all my own secret things. So I will be hiding my secrets after that, and I will be removing those things. But for now, just to save time and to let you connect and do your search, you can use mine. Right?
Sorry, Maria, can I just say one quick thing, just housekeeping. Later, so at 12:30 when this finishes, there will be an Our Ladies lunch at P11. So for every Our Ladies that wants to join us, we will be all there. And anyone else? Anyone else, yeah.
It's only for girls to invite?
It's lunch. Everyone is welcome. There will be a newbie session. So who is new with R? Saskia will match it up with a conference buddy so that you can ask questions and have your own little mentor for the conference.
Our ladies are very fantastic. I've been with them for since the start of the year. Now we do have some boys coming to the session, which is just fantastic. So it's not just because it's a ladies club. So it's not like exclusively ladies club. We welcome everybody. We are the boss there. So, but we definitely welcome you. It's so nice to have support and community there. Guys, it's a free lunch. Go there. All right? So let's have a look. So what I will be showing you are in the test file. So I would suggest that you go and have a look at them if you cannot connect. Now, I do have a backup for majority of my data files, and that's under YouTube tutorial data. So some of those requests that I will be putting through are quite bulky. Again, I told you, compared to YouTube, compared to Twitter, YouTube, they don't have those limitations. So I don't have to set up my cron job. I don't have to collect my information regularly. The minute I go there, it's there, right? So, but yeah, so the bad thing about that is that you can get a lot. So you have to handle it. And some of the functions that I'll be showing you, well, it can take up to half an hour to work, and we don't really have that much time, all right? So it's YouTube data, and otherwise go to the test. Now let's have a look. So some of those parts will be repeated with Twitter, just because it's the same approach, it's the same technique that we're using to collect some information. So for those steps, I will just highlight that it's similar, but I'm not going to stay because I think Anna done a fantastic job on that, right? So let's start with the first thing. So hopefully, can you see that? Do you want it to be bigger? So let's have a look. So first of all, we'll need some libraries that we'll need to install. Again, the most important library that we need is the tuba. Here as well. Alright, so we are going and you need the toolbar. Where's my toolbar? This one. So this library actually works with the YouTube APIs. Again, you can get away just by using HTTPR and JSONLite, but it will be a little bit more complicated doing it just raw. So I would suggest just make sure that you have a toolbar in the first place. And then some manipulations with the text. Again, we'll be using tidyverse and tidy text. So let's do the first thing. So what we're going to start with, we're going to start with connections. All right? So connections are pretty easy, so very, very easy. So again, I'm putting all my credentials here and I will be removing them. So you need to code yours. So set up your app ID, set up your app secret. Again, we will be connecting using that second option. You remember, API was the first option and the second option was the oath. So we're going to use the oath. All right? And then connection is really, really easy. So you connect using the YouTube oath function. So that function passes your application ID and your secret, and you leave your token blank because that will be returned to you. Can we all run it now? So you put your credentials. Can you run it for fun? If everything works, you will be taken to your Google page where you will need to approve access. So let's have a look. So it should look something like this. Does it work for you?
We did set up one for web applications and one for the hardware.
API key, right? So we set up the API key and you set up the other one, which is the oath.
Yes, we set up for the web application and then for hardware.
No, it's just me. It's me. I set up it for both. I was showing people. You need only one. But yeah, it doesn't, like, you take, just stick with something. All right?
I think when I put it up, it was called client ID and client secret. So that's what I'm going to call ID and secret.
Yeah.
Yeah. That's what it is.
Yeah, so you have those. So that's that one I'm taking from the Google from my Google APIs.
Yeah, but now you rename that in R. So now in R, it's called app ID and app secret.
It's just to be consistent. Like, you know, the problem here is that, yeah, I know you can continue. I'm just trying to explain. So it's called differently. It's just because these are the options that this particular function takes. So that's what creates the mess up, right? So you can use the same terminology. It's just what you're going to see when you go to the help page. You don't have to name them at all just because you connect only once. So what you can do under that function, you can just put your credentials there. Just don't mess up with names at all. Are you able to connect? You need to make sure that you install the library. So you need to go and install the package, right? So here I'm just making use of the library that's been installed. So if you need to install the library, you go to install packages. Right? So you need to run that one first. So you don't have to go with a particular last version of that because it hasn't changed a lot. So you just install whatever is available. Are you able to do that, guys?
I'm not connecting.
So you're not connecting. Yours, we'll have a look at them after, right? But for now, so can you use mine? Just copy mine from the file. right? So now we're connected. So when you're connecting, so what we're doing is I need to finish it up. So I select my account. You select yours. So you use my credentials to connect to yours. And I allow the application to run further. Right? So now we're connected. So you do that once and then you basically don't have to worry for a couple of hours. So they keep the session for quite a long time so you can relax basically. The only thing that I noticed, so if you start the first connection, so it's quite important guys. So if you start the first connection, just because access token is blank, it records it on the disk. So it caches it, right? And that's why when you try it next time, it just shows you nothing and it assumes that it's sort of working, but it doesn't give you any errors at all. So in this case, what I suggest, like there's a way for you to dig up your old and actually delete it, but I suggest just set your cache to false, and in this case, it will like try to reinstall the connection every time you do this. So it's a bit annoying thing, but it saves you a lot of time because otherwise you'll be just staring at the screen, waiting for your connection, and nothing is going to happen, right? So that's what I noticed. That's what works. Now, next thing. So let's start searching a while. Searching is really simple. Yeah, very similar to what Anna showed. Now, the function for that is YouTube search. It's a very, very generic function. You can search like whatever you want, right? So I was searching for World Cup, right? So you can search for whatever you want. So let's try let's simple things. Now, YouTube search function is really nice because it's generic. So everything, it just takes everything, right? Now, and let's have a look at the output. So in this case, I'm just putting the search term, and it's just the same way as you would go to YouTube and start searching for your term. So it shows you video ID. Now that number is going to be crucial because if you want to access that statistics for the video, this is what you will be using. Right, published ads, so you can play with that and see how the dynamics of those changes occur. Now, channel ID is another quite a crucial number, so you remember those nodes. So these are the nodes for YouTube. Channel ID gives you access to all the channels, all the channel-related information, and we'll be looking at that later. So it's just in depth, but you need to have that channel ID, not username, but the channel ID. Now, title, description, and there will be a few more, so there will be like type of resource, which I'm not showing here just because it's like really a lot. Now, so that's the YouTube function. Now, what you take as a parameter, you can specify your video ID if you know one. You can specify particular channel that you are looking at, and results. You know, because it's like really data is not restricted. So it can take a lot of time to download the data. So sometimes when you're downloading a lot, you may feel like you better split your data download into several parts. Right? Now, again, so that's the basic search. Anybody done any search? What you found? How many you found? A lot? Did you put the maximum? Which one are you searching for?
I just searched the World Cup one.
Oh, well, to be fancy, go for something else. Yeah. Does it work? Yeah. So it will return the results. Right? Does it work? Oh, good, fantastic. Now, what is good? Well, it's one of those functions that are pretty easy to, I would say, digest because it returns you a data frame. The difficulty with all other values that functions return will be the nested list that you have to deal with. So that was the same for Twitter. Well, with YouTube, the majority of that, because it's based on HTTP and JSON-Lite, so the majority of the data that you will be getting it in, unfortunately, nested list form. So you will need to dig it further, particular elements of that you need, and that may be a bit of hard job of its own, but yeah, I'll show you ways how to do this. So YouTube search is absolutely fantastic. Now let's move on and let's have a look at other things here. Now, so search function is just very generic. Next one, get common threads. So this function allows us to download all the comments for a particular video. And this is the source for your text analysis. So where we can get some video IDs, what do you think? In your previous search, when you search for World Cup or whatever you are searching, you have your video ID here. So just take one video ID and put it in your search for get common thread results. You have to be quite careful with the function because sometimes when there are too many comments, it can hang up. So you may need to restrict it. All right? Anybody getting any luck? So I'm searching for one of the function here, for one of the videos here, right? And these are the comments that I'm getting. So it shows me the author's name and the text display. So potentially I can take that text and analyze it later. Why? I want to see polarity, I want to see the mood, I want to see the tone. Like here I'm playing up with the World Cup. I can do the same thing for branding, for the brand, and see what is the reaction to a new product, what is the reaction to a new service introduced. Right? Now, as you see, what will be potential problems for us here? So before you start with analysis, you need to understand what are the cleaning parties. Cleaning of the comments, like Anna did like really well, cleaning will take probably 80% of your time, just because you have to be quite careful. Remember, rubbish in, rubbish out. As an academic with lots of your research going on, I know, like I've spent probably 80% of my time just in cleaning the data. The common weak points in the data that I know how to overcome, like missing records and the stuff, but sometimes you just, like with textual data, you need to have a feel of what you're looking at. Like when we're looking at here, what do you see? First, some comments are not in English. How I'm going to analyze them if they're not in English? What will be the ways for that? There are dictionaries, and we'll be looking at dictionaries later when we're going to look at semantic analysis. They allow you to work with different languages, but are you going to split your data set? How exactly you're going to split it up? All right, now we'll have a look at numbers. Numbers are usually removed from the analysis. Do you need to remove them? Numbers can be quite important because here we're searching for what? We're searching for football games, all right? So numbers can make sense. Now, we'll be looking at hashtags with Twitter. Now, here, you can have some special symbols. Emojis, somebody was talking about emojis. You know, just going back to emoji page, there's a fantastic tutorial on how you analyze emojis there. Now, the idea behind that is, again, cleaning up your data well. So in this case, we're not using regular expression just to get rid of them. We're going to recode them. So we're recoding them into a more human-like description of the impression, right? So we're recording them, and there is already a dictionary prepared for us, which we can use later to analyze it. All right, but let's get back to ours. So the most important thing, so once you got your data, you have to have a look at it. And all the manipulations that Anna was showing you, they definitely were going to work, but you need to know which one do you need to do. Do you really need to convert to lower cases, or would a lower case be some tone expressed in that, right? So let's move on. So get common threads, anybody tried that? Anybody getting any comments? All right, fantastic. Now let's move on. So at this stage, so we've searched for videos, we searched for comments. Now let's move on. Now I'm going to skip a couple of things here because they're sort of repeating each other. And now let's have a look at channel stats. Now, what is a channel? Channel is a node at the YouTube, and we're going to have a look how that node is organized. Now, to get access to channel to the YouTube channel, you need to have channel ID, right? So that's what we talked about. Now, my question is, anybody knows how we can get channel IDs? All the names that we have are just YouTube names. They are nothing for R, and you will not be able to use it in your search. So let's have a look. There are ways for us to have a look at it. And the first way is YouTube Data API. Do you remember I mentioned? YouTube Data API is just a fantastic way for all the developers to get some information from Google API. So let's have a look. So for us to get channel ID, we need to have our own API key, and we need to know the channel name. And this is the line that I will be using. So this the line is like all the documentation is available at Google Developer Console, and you can get access to that in Google API. Now, so let's do what? Let's work out what is the channel ID for the channel that we're going to explore. So let's copy it around. Right? And I'm going to a blank page. Now, it's not going to work at this. As you see, it returns all the blank things. So what do I need to do? I need to put my API key at this part. Do you see this? Tiny, tiny, tiny little bit. Yeah, I'll probably put it in the Word document. All right? So what you need to have your API key, and you need to replace this line with your API key. And you need to have a username, which is the username for the channel. Now, in this case, I will be playing with some analysis and textual analysis of 3 channels. I will be looking at Victoria's Secret versus Vogue. So I want to compare how the textual tone, how semantics changes in the channel itself, and the comments that people are leaving there, right? So, are you able to change the line to get your IDs? Now, let me show you how it will look like eventually. So, blank request will not work, so I need to adjust it. So, let's have a look. So this is the request that I'm putting through. That request has my API key over here, and as a user key, I'm putting Victoria's Secret. So look, where's my API? So that's my API. I'm copying it. And now I'm going here. And I'm putting it as my API key. And now username. So let's have a look. So what I need to dig out from here, I need to have this channel ID. So that's the easiest way for you to do it. Have you got it? So you can get, so that's the simplest way to get channel ID for any channel that you have. There are alternatives way of how you can do this, but it will be a little bit more complicated. All right? I will get it, guys? So just copy it. So I do have that code in my slide. So have a look at that. Now next thing. So where are we moving? Alternatively, so if you don't really, you can get your channel IDs just from the page. So just open the page at the YouTube and view your source code. Now in the source code, your source code will look something like this. Horrible, I know. If you don't know it. So what do we need to look at? You need to search for external ID, or data channel external ID. That can give you the same number as well. But from my experience, it's much easier to go with Google API. So once we have the ID, we're all set. So now what are we going to do? We're searching for video, and now we're using our channel ID as a search. So we're back to our old friend YouTube search, and we're searching it here. All right? So it generates the response, and now most important part of that response is that I have video IDs. All right? So video IDs. Now I have a title and I have a description. Title and description are potentially two yeah.
So I didn't get the channel ID when I used the Google API.
So what is showing you?
It's showing
Blank?
tag, basic, full, but there is
Are they empty?
no ID.
Are they empty?
No, the fields are not empty. There is information, but there is no ID. But
Can
I
you-
get it from source code.
Can you make sure it has to show, because it's like surefire way of getting it. Can you make sure that you put the name of the channel correctly?
Yeah.
So it's double S in there.
I was searching for some other channel.
Oh, it should work. It definitely has to return it. Do you want me to have a look at that later? And we'll have a look why it doesn't work. Yep, fantastic. All right, so now, so we have this, so what do we do next? So we're getting a list of them. So we're getting, so potentially, so we have title and we have a description. So we have three sources of textual information. We have a title to analyze. We have a description of the video to analyze. They are provided by the channel owner. And now we have comments to analyze as well, right? So all these nodes, they come with textual and non-textual information, which are potentially a wide source for analysis further. Now let's move on. What we're going to do next? Now, let's have a look at channel stats. So that's the simplest thing. So we use the channel, get channel stats function for this. So can you all run this? Get channel stats, channel ID. Somebody was asking the question if we can get some information, some basic information about subscribers, views, number of videos. So that information is in get channel stats function. Now, if you run that function, so if you don't assign it to a variable, it will return a whole lot. Now, if we assign it to a variable, I have a variable to show you. Your variable will look like this. It's a nested list. So this is where you have to dig it up a little bit. So you cannot just convert it, so you need to convert a particular part of that. So all the information that you need are here on the statistics list. So we need to dig out that statistics. All right? So how we do this? I'm going to show you once, and then it will be just basically the same thing. So we are referring to a particular element of the list and the different ways how you do this. And then we do call and abide function. Now, what I noticed, and probably like you know that as well, so do call and abide, they works only when you have your list with equal number of elements. It will not work if number of elements are not the same. So if for some reason when you're trying to, like not on this simple manipulation, but later, because we're going to work with nested list further, if it doesn't work with your nested list, it doesn't convert, it shows you errors that you have different number of elements, what you can do, there's a fantastic function which is rbind list from data table package. Right? So I would highly suggest using this one. And that function is actually much faster than do call rbind. So this one is good. Now, if it shows you error, it's not for this one because it will it's all good because it's under one channel, so all the elements will be the same. So if you call rbind list, make sure that you put field parameter to true. If you put it to true, it will go into substitute those missing values just with zeros. Right? Now let's move on, guys. We have only 5 minutes and we have to do all the analysis. Now, let's have a look at more exciting things. So let's assume, so I do have all the files here. I just want to show you how we can analyze the textual information there. So for textual information, again, we're going to use tidyverse and tidytext for all the data manipulations. And again, steps will be absolutely the same as what with Twitter. It's just the same type of information. But there will be a little bit more exciting things that you can do with YouTube data. Scroll down to that. So let's have a look here. So I have my titles and I have my comments at this stage. Now I do have the backup files here under the data for YouTube tutorial. And now if you want to have a look, so I'm going to have a look at video stats all CSV file, which has 2 channels, which have data from 2 channels. So I'm going to compare these 2 channels. So it's American Vogue and Victoria's Secret. Now, make sure that when you work with your tidy text and tidyverse, set your strings as factor to false. It will cause you problems if you leave it as they are. All right? Now, these are my comments. So what I can do with them, all right? So it's a basic analysis of likes and dislikes. I think you got it from Anna, so let's have a look here. So I'm taking all my video stats, I'm doing all the common manipulations, and I'm summarizing into frequencies. So I want to see how frequently words are used. Compared to what they did with Twitter, I have 2 sources. So I'm going to group by source and see what is the frequency for each of the source and which words are particularly popular there. So as you see, they're quite different. All right? Now, frequencies between Vogue and Victoria's Secret, very, very different. And I put them on a graph so it makes more sense. So have a look. That's the word cloud for Victoria's Secret. And that's the word cloud for Vogue. Just looking at that, what do you think? It's all the girly stuff. Do you have, if you just have a brief look here, do you see any particular semantic differences in the word choice? It's too girly, all right? As compared to Vogue, so what do you see here? Still a girly things, but it's a bit more complicated. All right, so different word choice and different word frequencies that they are using. Now, yes, it's the same word cloud too, fancy things. Now, this is the part that they haven't covered here, and very, very unfortunately, we don't really have that much time. We're going to look at the sentiment. Have you heard about sentiment? So a sentiment is the tone, is the voice of the text, all right? So it's not the tone, it's like how loud I'm saying it, but what's the message that I'm putting through, right? So we understand the text not only in terms of words, but we also try to feel what is hidden there. Now, there are different dictionaries, and all sentiment analysis is based on the use of dictionaries. So use of dictionaries is a collection of words classified into sentiment. Depending on the dictionary, there are different ways how this can be done. One of the popular dictionary is a theme dictionary. It's pre-built in tidytext, and it assigns word to scores between -5 and 5, depending on how negative and positive. So it's a polarity of the text that we're trying to assess. So if we're talking about some negative things, what do you think? The polarity will be somewhere in the 0 range. If we're talking about positive things, that will be somewhere in the positive range here. So you can get access and have a look at what do they have just by typing get sentiment. So again, it's pre-built. You don't have to do it. So if you get sentiment, so that's what they're using to assess your text. Now, what are we going to do? We're going to take the text which we digged out from the YouTube, and we're going to apply our sentiment to see what's the proportion of words with different tone that we have in the text. Does it make sense? So we just compare. That word is here, we do have it. Do we have it in the dictionary? We do have it. What's the polarity of that? Is it negative? Is it positive? So Affine is using negative numbers and positive numbers. Bing, that's another dictionary, categorizes it into negative and positive and neutral. So that's another way for us to assess it. Right? Another widely known dictionary of sentiment, NRC sentiment. Now it's a bit more complicated here, so apart from positive and negative, they classified into anger, anticipation, disgust, fear, joy, sadness, surprise, and not trust. You don't have to fiddle with dictionary at this stage. Well, you can, if it doesn't work, but you can just take the ready-made dictionary and apply it to your text. Right? So when do we do this? You take your text, you prepare your text, do all the cleaning that Anna was talking about, and then you just take the ready-made dictionary and apply it. The dictionary classifies your text and calculates the proportion of positive, negative, or whatever other categories you have in the dictionary. And in the end, it shows you a summary. How would the reader will assess your test? So let's have a look. So I'm doing this I think I'm doing it for titles. So have a look. I'm putting all titles in my sources. So doing the cleaning, and now I'm putting it through the sentiment. It's very, very simple how you apply the sentiment. So you just use the get sentiment function and apply it to your words. In my case, I want to know who is more joyful, who is more happy, which source gives me more. So that is why I'm grouping by source. You can do the same with just individual titles to see which title is more joyful, right? Now, that is used a lot in stock exchange trading, in automatic trading. Why? They look at news and they try to assess the polarity and sentiment in the news. So if the news mentions a certain company and the sentiment is positive, it's likely that the share price for that company will go up. So it automatically starts doing what? Time is money. The earlier you start buying shares for the company, the more is the money that you will be making in the end, right? So let's have a look. But in our case, we're just back to girls. It's pretty simple, right? So we're trying to compare these two sources. So Victoria's Secret and Vogue, what do you think? These are the sentiments that we're splitting into categories. Anger, anticipation, disgust. Well, they're all really nice, right? But have a look. They're quite interesting here. So who is more trustworthy? So Vogue is more trustworthy, right? So trust. We're looking at titles and what's the tone of the title. So if you look at the tone of the title, the word choice is more trustworthy. Develop trust in your reader for Vogue. Now, let's have a look. Positive. They're all very, very positive, right? But probably Vogue is a little bit more positive than the other one. On negativity at the same time, you see, so Victoria's Secret's titles are very neutral in their approach. So it's, with Vogue, you have positive and negative, just balance between. Now, who is more joyful? Yeah, it's the same. Does it make sense, guys? So it's very, very simple. Like you can get your classified words here as well. I'm just as an end point. I'm just showing you on the graph as a way to make it more visual. And probably we don't have time for topic modeling. The slides will be there, so you can go and have a look at topic modeling. It's really nice. I'm doing topic modeling on description to see how companies attract the reader. For all these brands, it's really important to attract the audience and keep it. So how the word choice, how the use of topics
track the reader and keep it going. So the very last one. So I applied a different sentiment here. And I applied it to comments. So if I have a look at comments for 3, I'm looking at Vogue, British Vogue, and Vogue, and Victoria's Secrets. So I have a look, who is more positive, who is more negative? Oops. All right, so these are just analysis of comments. So that's the negativity comments, and that's the positivity scale. So in terms of negativity, you see Vogue is pretty neutral, right? Though they were scoring high on the title, they're pretty neutral in comments. At the same time, if you go to British Vogue and Victoria's Secrets, they're very, very high on negative comments. And at the same time, they're quite high on positive comments as well. All right? That makes sense? So applying sentiment is really quite straightforward with the use of tidy text. It's just what you're going to do with that. Companies are increasingly looking at sentiment analysis, and you can apply sentiment analysis to lots of things, depending on what sort of outcome you're going to get. It can be news, it can be like YouTube. As long as you can get textual information, it's like really, sky is the limit. Right? So we're finishing up. I do have set up like that last bit with topic modeling. It's really nice area to go. Very, 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 very promising, but a little bit too complicated, so I'm simplifying it. So hopefully you can enjoy it on your own when you do your reading. And we're finishing up. All right? So thank you all for coming. Hopefully you can take something away. Well, definitely we set up those connections. So definitely you can go home and you can try all the practical exercise that we have here. So hopefully you enjoyed it. Thank you so much.